unbiased estimator. Unbiased estimator. Okay, suppose what is biased and unbiased estimators? Suppose a statistic T is called unbiased estimator of parameter theta if a statistic T is called unbiased estimator of parameter theta if E of t equals to theta. Okay, so T is one statistic, theta is one parameter from population. Okay, T is statistic. A statistic T is called unbiased estimator of parameter theta if E of t equals to theta. If E of t equals to theta, T is statistic, corresponding parameter is theta. If E of t equals to theta, then T is unbiased estimator of theta. And it is biased estimator if E of t not equals to theta. Okay, T is one statistic and the parameter in that corresponding population is theta. If E of t equals to theta, then T is unbiased estimator of theta. It is unbiased estimator of theta, and it is biased estimator of theta if E of t not equals to theta. If E of t not equals to theta. See one example. Example is population mean, sample mean x bar is unbiased estimator of population mean. Mu. Okay, sample mean x bar is unbiased estimator of population mean mu. That is E of x bar equals to mu. E of x bar equals to mu. E of x bar is sample mean and E of x bar equals to population mean. So x bar is unbiased estimator. Of population mean. Okay, x bar is unbiased estimator of population mean. But sample variance S square is biased estimator of population variance. Sample variance S square is biased estimator of population variance sigma square. Sample variance S square is biased estimator of population variance sigma square. That is E of S square not equals to sigma square. E of S square not equals to sigma square. Sample variance S square is biased estimator of population variance sigma square. So E of S square not equals to sigma square. See, we know that E of S square is n minus 1 by n sigma square. E of S square equals to n minus 1 by n sigma square. So E of S square not equals to sigma square. because n minus 1 by n is not equals to 1. So E of S square not equals to sigma square. So sample variance S square is biased estimator of population variance. But E of small s square equals to sigma square. E of small s square is sigma square. E of small s square is sigma square, where small s square equals to n by 1 minus 1 capital S square. See, E of small s square equals to sigma square. E of small s square equals to sigma square. So this statistic S square, small s square. So small s square is unbiased estimator of sigma square. Small s square is unbiased estimator of sigma square. What is small s square? Small s square is n by n minus 1 capital S square. So small s square is unbiased estimator of sigma square because E of s square equals to sigma square. So this is unbiased estimator of sigma square. What is s square? S square is n by n minus 1 capital S square. Okay, but sample variance capital S square is biased estimator of population variance. Okay, see one example. See one question. If x is unbiased estimator, if x is unbiased estimator of A, then x square is biased estimator of A square. Okay, x is unbiased estimator of A. X is unbiased estimator of A. Question is prove that x square is biased estimator of A square. X is unbiased estimator of A. So E of x equals to A. E of x equals to A. Question is prove that x square is biased estimator of A square. X square is, so we have to prove that E of x square not equals to A square. E of x square not equals to, prove that x square is biased estimator of A square. So we have to prove that E of x square not equals to A square. Okay, we have to prove that. Given that E of x equals to A, prove that E of x square not equals to A square. Suppose that E of x square equals to x. Okay, just consider E of x equals to A. We have to prove that E of x square not equals to A square. We suppose that E of x square equals to A square. E of x square equals to A square. Now, var of x. What is var of x? Var of x is E of x square minus E of x whole square. Var of x, variance of x formula is E of x square minus E of x whole square. Variance of x equals to E of x square minus E of x whole square. Variance of x. Now E of x square, it is a square minus ex is a, so it is a square. So var of x equals to 0. So var of x equals to 0. Now x is one statistic, it is not constant, it is variable. So var of x cannot be 0, but we are getting var of x equals to 0. So our assumption is wrong. So this assumption is wrong. That is E of x square not equals to a square. Okay? See the question once again. If capital X is unbiased estimator of A, prove that x square is biased estimator of A square. So E of x, it is A, because x is unbiased estimator of A. So E of x equals to A. Prove that E of x square not equals to A square. And we consider E of x square equals to A square. Okay, no problem. E of x square equals to A square. Now calculate var of x. Var of x equals to E of x square minus E of x whole square. E of x square, it is A square. Ex is A, so A square. So A square minus A square, it is 0. Now, so var of x equals to 0. Var of x, it is 0. It is possible when x is constant, x is constant, that is x is not variable, okay, that is not possible, okay. X is unbiased estimator, so it is not constant, this is variable, okay. So var of x equals to 0, that implies x is constant, this is not possible, okay. So our assumption is wrong, that is e of x square cannot be a square, so e of x square not equals to a square, okay. Okay, next problem. If T is unbiased estimator, if T is unbiased estimator of theta, then root T is biased estimator of root theta, okay. T is unbiased estimator of theta, prove that root T is biased estimator of root theta. So T is unbiased estimator of theta, so E of T equals to theta, E of T equals to theta. Question is, prove that root over T is biased estimator of root theta. So root over T not equals to root over theta. Root over T, E of root over T not equals to root over theta. Okay, we have to prove it. Suppose that E of root over T, suppose that E of root over T equals to theta. Okay, just consider E of T equals to theta and E of root over T equals to theta. Now calculate E of root over T minus root over theta whole square. E of root over T minus root over theta whole square. E of. So this is E of root over T whole square, that is T, plus root over theta whole square, that is theta, minus 2 root T into root theta. Okay. So this is E of T plus E of theta minus 2 E of root T root theta. Okay. Now E of T it is theta, E of T equals to theta. Theta is constant, so E of theta is theta minus 2, theta constant, so this is 2 root theta E of root T. Okay, E of T it is theta constant, this is variable and this is constant, so E of theta equals to theta root theta outside, so 2 root theta into E of root theta, so this is 2 theta minus 2 root theta into E of root theta, E of root T, E of root over T, E of root over T, it is root over theta, so this is 2 theta minus 2 theta, it is 0. Okay. E of root over T, it is root over theta, so 2 root over theta into root over theta, that is 2 theta, so 2 theta minus 2 theta, it is 0. So E of root over T into root over T minus root over theta whole square, it is 0. Okay. So this is possible only when this E of root over T minus root over theta whole square, it is 0. This is possible only when this term is 0, root over T minus root over theta whole square equals to 0. If it is 0, then only E of root over T minus root over theta whole square 0. E of root over T minus root over theta whole square, this is 0 only when this term is 0. So root over T minus root over theta equals to 0. So root over T equals to root over theta. That implies T equals to theta. That implies T equals to theta. Root over T equals to root over theta. That is T implies T equals to 0. This is not possible. This is not possible. So our assumption is wrong. That is E of root over T not equals to root over theta. Okay. See question. T is unbiased estimator of theta. Prove that root over T is biased estimator of root theta. So T is unbiased estimator of theta. So E of T equals to theta. Question is prove that E of root over T not equals to root over theta. We consider E of root over T equals to root theta. Now calculate E of root over T minus root over theta whole square. Okay, that is E of root over T whole square. That is T plus theta minus 2 root over T root over theta. E of T plus E of theta minus 2 root over 2E root T into root theta. E of T, it is theta. This is theta minus theta is constant. So outside this expectation. So 2 root over theta into root T. This is root T. E of root T equals to root theta. Just put here. It is 0. So E of root over T into root over theta whole square, it is 0. This is possible when it is 0. So from here we are getting T equals to theta. This is not possible. Okay. So our assumption is wrong. That is E of root over T not equals to root over theta. E of root over T not equals to root over theta. That is root over T is biased estimator of root over theta. Okay.